Welcome, everyone. We're really excited to have you here today for our weekly deep dive series with OCI Product Management. For anyone who might be new to our events, we're hosted on Cloud Customer Connect, which is our Oracle community forum for end users. I'll drop some links in the chat throughout today that will lead you back to the CCC forums. So if you don't already have a free account there, we invite you to create one, join in some discussions, look for upcoming events on all kinds of topics. My name is Kenna Ketrick. I'm a program manager with the OCI go-to-market team, and today I'm joined by Samuel Kops, Senior Principal Product Manager here at OCI. Today he's going to walk you through the new preemptible instances, how they differ from on-prem, and various ways to use them, including some demos. Before I hand things over, though, I do have one quick poll to run. Anyone who's joined us before might find this familiar, but I'm going to pop that up there for everybody. We design these weekly sessions with our users, you, our customers in mind. So each week we put you in touch with product managers and developers, and I always like to know what you are interested in so that I can tailor those sessions to what you'd like to see. So if you want to drop your thoughts in that poll, that'd be great. Speaking of upcoming events, we do have two next week. On Tuesday, the 27th is the second of our 6-session series, Day 1 and Beyond, which is a step-by-step fundamentals on how to get started on Oracle Cloud. And on the 29th, we're hosting Jim Smith to showcase and demo the new OCI Vulnerability Scanning Service, which is a simple, on-by-default, prescriptive, and free scanning suite tightly integrated into the OCI platform. I'll drop links to both of those events in the chat, so we hope you can join us for that as well. Quick reminder, as usual, please use the Q&A box down at the bottom of the screen. There'll be someone answering questions throughout the event. We'll have some time for live Q&A at the end as well. And we are, of course, recording this, and we'll have a replay up. So if you have colleagues that were unable to make it, but you think might be interested, then we'll have this up and we'll drop links in where to look for that as well. All right, I think that is more than enough for me. Take it away, Samuel.
Hi, folks. Thank you for joining today. It's a pleasure to be here. Excited to talk to you about preemptible instances, a new capability that we have shipped in OCI, available to you, primarily intended to give you access to capacity at a substantial discount over on-demand instances. So let's talk about what we're going to cover today. We're going to focus on preemptible instances. Before we get into that, we need to talk about what interruptible workloads are. Preemptible instances are designed for running certain types of workloads. We call those interruptible. We'll explore what that means and, help you learn how to identify an interruptible workload versus other types of workloads. Then we'll get into the details of preemptible instances. We'll introduce the concepts involved and go through the details of the preemptible experience. And then towards the end, I have a few demos to get you started, including how to create preemptible instances and a quick setup you can do to test and explore the preemptible reclamation event notice. So let's start off with interruptible workloads. And again, this is important because when we talk about preemptible instances are designed for interruptible workloads. So what is an interruptible workload? So when you step back and you think about all the different types of workloads that run in cloud environments, typically what comes to mind right away are things that require continuous availability. Often workloads need to maintain complex state. They may be time consuming to set up. A lot of workloads are also sensitive to latency, and these are kind of your bread and butter cloud workload scenarios. You could, for some examples of these, you could consider, for example, database servers or real-time communications or even video streaming. These things are need to be very responsive. They need to be available very predictably. Now, contrast that with other types of workloads that typically don't get as much attention. They're not the majority, but they make up a surprisingly large percentage of most customers' workloads. We see 10 to 20, even 30% of workloads fit in this bucket. And that's workloads that can be deferred, can be restarted, can be executed flexibly. And we consider these interruptible. Typically, they have very little application state they maintain, or potentially they're very easy to configure and start, so they can be spun up on demand. Alternatively, they can be flexible in their execution scheduling. You could potentially say you have workloads that need to run once a day, but they can run at any time during the day. Now, these are what we call interruptible workloads. And the punchline is basically interruptible workloads can run on instances that have different execution expectations, specifically lower availability SLA. Now, when you take a look at a compute instance and you say, what do I expect the uptime to be? If you have a lower availability SLA, typically that comes with a lower price. So we're going to keep coming back to this point today that interruptible workloads can run on instances with a lower availability SLA, to give you a net reduction in your compute charges. So let's get a little bit deeper on interruptible workloads. It's very important to be able to look at your workloads and say, is this interruptible, is it not? So let's look at some categories to help start to build a framework here for how to categorize things. We think of three large buckets. You can get interruptible workloads in a variety of scenarios, but generally they kind of coalesce in three buckets. The first is dev test workloads, and that's often internal engineering activities, typically somewhat flexible in their execution schedule. A couple of examples right off the top are automated test suites or potentially scale testing. These are the kinds of things that you can, the sensitivity to when they run is somewhat flexible. For example, let's say I have a code change as a developer, I check it in, I want automated testing to kick off and run right afterwards. Whether that runs 3 or 5 minutes afterwards may not be as much of an issue, and you can see that you would have some flexibility there. Alternatively, looking at scale testing on the other end of the spectrum, we think about, say you're about to push out a big change to your cloud topology and you want to test the new architecture at scale to make sure that you're not introducing any new performance problems. You set up some, either a complete clone or a small version of your production environment and staging environment. You beat on it for a couple hours, see if there's any performance problems that come out. Again, you can see how that might be somewhat flexible in when you do it. Maybe you do it for a certain duration of time. If there's a problem, you can start it, restop it. So examples of dev test workloads. Another unrelated category is batch jobs. And these are typically easily restarted. They may be one-off batch jobs that are run on when needed, or they may be periodic. Examples include ETL jobs, big data analytics, or even machine learning inference, not machine learning training specifically. Let's differentiate that. Many times batch jobs are run and they're expected to fail once in a while, and that the failure recovery can be built into the batch job, or it's just expected that periodically they're restarted, or failures can just be ignored and the batch jobs can rerun again on a schedule. And again, because that gives you some degree of flexibility, you don't necessarily need to worry about the responsiveness or being absolutely sure that the availability of the compute that's running those is 100% continuously available, excuse me. And then in a completely different area, we have fault-tolerant workloads. And these can be very complex, mission-critical, large applications. And because of their scale, they're built with the assumption that failure is inevitable. CI/CD is a good example, simulations, massively parallel simulations specifically, as well as very large web server fleets. Whenever you start using more than a certain number of instances spread over a large enough network area, you have to architect your workload to assume that there will be intermittent failures. And these types of workloads often have a built-in orchestration mechanism which detects the loss of specific nodes, like worker nodes or specific instances, and is designed to recover from that, either by creating new instances or potentially shifting work to other nodes and picking up the processing that was handled on the lost node. Now, because that is built for a model where there is an assumption that there will be instance loss, we consider these interruptible as well, because there is an expectation that at any point, parts of the entire workload may fail and is designed to recover from that. So these are some categories you can think about. You're saying, hey, I have all these workloads. Are they interruptible or not? You can think about these specific categories. Now, to help you think even more about which individual workloads are interruptible, there's some questions you can ask when you look at a specific workload. And you can say, is it easy to restart this? If it fails, I just say, well, no problem, restart, run again. Good candidate is an interruptible. Another question you can ask, is the scheduling very specific? Do I have very aggressive SLAs, or can I run this any time in a day and it's okay as long as it completes by the end of the day? Another good candidate. And a deeper telltale sign is if you're looking at your architecture more closely and you realize that any relevant state that's maintained is completely independent of instance lifecycle, that's a really good indication that this may be an opportunity for you to think about it as an interruptible workload, and as we'll demonstrate, something that could potentially run on preemptibles at a much lower cost. Now, flipping that on its head, let's look at some signs that things probably are not interruptible. For example, if you look at any workload and there's anything really critically time sensitive about it, if you measure your response rates in milliseconds or seconds, probably not a good candidate. Another key sign is that setting up the workload is expensive or takes a long time. For example, a database server. When you configure a database server, you probably don't expect to do that in response to a customer request in real time. Those kinds of things, not good candidates for interruptible workloads. And then another thing to look for is whether or not your state maintenance is complex or changes rapidly over time and needs to be managed very carefully. Those kinds of things generally are not the best candidates for interruptible workloads. Now, that being said, this is a little bit of a framework to help you think, start differentiating workload A from workload B. Is this interruptible? Is it not? I will caveat that with enough engineering investment, you can make almost anything run as an interruptible. It's kind of a platform investment type of activity. For example, you could theoretically do real-time communications over interruptible workloads. It would just take a lot of engineering work. So depending on your level of investment, you could make pretty much anything function as interruptible. It's really a question of how much effort you want to invest. In this conversation, we will focus on workloads that by definition and by their very nature align to this pattern or do not. And we'll focus on those as a cost-saving opportunity for you. So that's a little bit of an overview about the difference between an interruptible workload and other types of interruptible workloads. So with that context, let's talk about preemptible instances. And I'll just get right to the punchline. Basically, a preemptible instance is the same as an on-demand instance, but we don't offer an SLA on it. And in doing so, that allows us to offer it to you at a much lower price. Everything is very similar or identical with an on-demand instance, with the one caveat that OCI, if under capacity pressure for any reason, can take back a preemptible instance after a short warning period. So you can think about this like today, you have your on-demand instances, they're yours as long as you want, you pay only for what you use, and you never think that they may vanish. That is the key difference with preemptible instances. You may get a notice at some point that OCI needs the capacity back, and it will terminate the instance. Now, this is the trade-off here is that you get a 50% discount compared to on-demand rates, and that is off the price you pay. That is not directly off the list price. So if you have UCM negotiated rates, it's going to be 50% off the price on your rate card. A little bit of a trade-off here, but quite a substantial price discount. And as far as the performance of the instances, they're identical. I mean, they run on the same hardware as on-demand instances. There's really no difference between a preemptible instance and an on-demand instance when they're running. They're just much cheaper, and you have a different instance lifecycle you need to think about. They're just as easy to manage as well. You use the same management experiences. I'll show you a little bit of detail about that. And if you want to get a notification, if OCI needs to take a preemptible instance back, there's an easy way to do it through the event service so that you can take action if you want to, for example, save state or request a new preemptible instance. And I'll show you more details about that. But key takeaway here, you think preemptible instance, think on-demand instance, just it may be reclaimed by OCI if OCI is under capacity pressure. Now that we're thinking about this, let's think about what this means from a computing model change. Really what preemptible instances imply is a completely different way to think about compute. And this comes down to the reality that preemptible instances are essentially ephemeral compute. And what that means is it exists, but it can be taken away. It's there, but you can't always assume it'll be there. So you need to change how you think about instance provisioning, and you need to structure your workload under the assumption that capacity you have available may not always be available. And again, that does not align well with some workloads. Other workloads align naturally to that model, and that's the intent of preemptible instances, is to support that model at a lower price point. And when you get into those kinds of workloads, typically what you're seeing is that the activities you are doing in your processing are best effort. Usually they succeed, occasionally they fail, and that's okay. Either it is just definitionally best effort, and that's all you really need, or failures are easily managed via restarts or compensated by other mechanisms. And once you think about it in this category, you have this different life cycle you go through. Creating instances becomes part of your workload. The provisioning is actually something you do during workload execution. You think about monitoring the instances if you care. Not every use case requires you to even do that. Restarting instances may be part of your workload as well. You think about this different life cycle, and the key difference being that the instance management actually becomes part of the workload. So that's a quick overview of the model. Again, just to recap, basically preemptible instances are the same thing as on-demand instances, with the one caveat that under capacity pressure, OCI may take the instance back after a short warning period. And the trade-off is that you get it at a much lower price point. So let's think about what that means. On the upside, obviously you can reduce your costs. Anything that you're running today on-demand instances in any environments can be put on a preemptible instance and run at half the cost. So that's great. The other way to think about this, and semantically it may seem similar, but in practical application it's a little bit different, and that is you can actually increase your available capacity if you're working with a fixed budget. And we hear about this a lot when we're talking about people doing scale testing on a fixed budget. They go out there and they maximize their spend, and that leaves them with a limited fleet size. When you switch over to preemptibles, obviously because the costs are half, you now have twice the available capacity given a fixed budget. So if you're doing something like scale testing, that gives you twice the available surface area to do testing, which is typically better. And another implication of this is sometimes people create instances which are kind of transient. You're building, you have instances that are doing periodic things, and it's easy to forget about them. It's easy to have a bug in a provisioning script, and sometimes instances accumulate. The good news is with preemptible instances, eventually OCI will come for every preemptible instance, and you don't have to worry about leaking resources for anything you're running on preemptibles. If you forget about an instance, OCI will eventually clean it up for you. So it helps from that perspective as far as preventing resource leaks. So those are some of the benefits. Trade-offs, obviously, this is a different computing model. It might take a minute for you to think about this, saying, wow, I have to think about provisioning as part of my workload. Often that's already there. It's just moving your activities from one place to another. So it may not be a lot of work, but you do need to think about what you would need to change in your workloads. There may not be anything. There may be some small changes. The biggest issue here is just making sure you understand the life cycle. You need to clearly understand the difference between an ephemeral compute model and a persistent compute model. And this is the former, obviously, in that it's opportunistic compute for you to take advantage of at a discount. And the other thing to keep in mind is because an instance can be taken back, there may be occasional latency injected to workloads. For many workloads, that doesn't matter. If I have a batch job that needs to run once a day and it runs for about an hour, but it needs to run just sometime during the day, if for some reason I have to restart that, that's not a big issue. But if you have things that are very latency sensitive, there is an impact there. Again, we would consider that those are probably not the best candidates for running on preemptibles in general. So that's a quick overview of preemptible instances, interruptible workloads. We're going to go much more into detail. That's just kind of a high level to get your head around the topic. Now, we in the product side are obviously constantly hungry to get to know our customers better. So I have a quick question for you to answer here. Now that you have an idea of what an interruptible workload is, think about all of your compute instances and think across all your different environments. That's on-premises, cloud, regardless of provider. And let us know what percentage of instances you think are actually running interruptible workloads. Yeah, so we're seeing a pretty interesting distribution here. I like to give feedback or let you folks know what we hear. It looks like we see most of the most people have over 5% of their workloads in this bucket. Quite a few actually have over 20%. So pretty good distribution between 5 and 20%. So thank you for sharing. If you haven't answered yet, please do so. We'll go ahead and move on. All right, let's get into the details of preemptibles today and what we offer. Today, preemptibles are available on X7 Standard and E3. We have support for pretty much every VM shape coming soon. We will not support E2.micro or dedicated virtual machine, but pretty much everything else, including legacy shapes, is coming soon. Preemptibles are available in every tenancy, in all public regions. And as I mentioned, there's a 50% discount. That discount applies across regions and shapes. And this is actually a very important point. There are some similar products in market today that they're called spot instances, and they use a little bit different model. And it's important to drill into this, understand the difference. The discount offered by OCI is constant. It's 50% off the price you pay every region, every shape, every day, and that won't change as we add new shapes. The similar product, the spot instances, they use what's called a market-driven pricing strategy, or demand-driven pricing. What'll happen is the price will change depending on demand. It's very appealing because you think, wow, the price could go really low. It can also go really high. We've seen that it's not unusual for spot rates to approach on-demand rates, and it's very unpredictable. We believe that it's much better to have a fixed discount that is consistently lower price, that you know exactly what you're going to get. We've done some comparisons, and almost universally we went on price up to 38% cheaper than comparable spot instances. And I do want to point out, you may see on some other products, they may have a higher discount rate. I do want to remind you, our prices are lower to start. So if you're doing the math, make sure you take a look at what the price with the preemptible discount is. You'll see that OCI is almost universally cheaper by a significant amount. So today, this is available in the console, the API and CLI and Terraform provider, just like on-demand provisioning is. We've done a lot of work to try to make it as similar to the on-demand experience as possible. In most cases, creating a preemptible is no different from creating an on-demand instance, including or up to the point of just simply having to specify a single additional option. And preemptible instances use the on-demand limits and quota. So for an oversight perspective, you do not need to worry about doing anything different right out of the bat. You have the same oversight. We are considering in the future adding separate limits and quotas. We'd love to hear your feedback on that, but today it uses the existing. So let's look at the experience itself in the console. Just creating a preemptible instance. If you're familiar with the OCI console, you'll see on the right here, I have listed the instance creation form. To create a preemptible instance, you do all the same things you would do with an on-demand instance. You go and specify the name, pick your AD, and then if you click on Show Advanced Options, you'll see that a capacity type is available as an option, and that's on demand by default. If you select preemptible capacity, the instance you create will be a preemptible instance. And really, that's the only difference. If you specify, everything else is pretty much the same. You select the image you want to use. You select the shape. As of right now, you'll need to select a shape that's supported by preemptible instances, but everything else is the same. And then you click Create, and you have a preemptible instance. So it really is that simple. The other experiences are similar in their similarity to the on-demand instance creation experience. I want to spend a little bit of time talking about the instance reclamation event, specifically the notice. This is the big difference. If you can understand instance reclamation and you know what on-demand instances are, you probably know pretty much everything you realistically need to understand about preemptible instances to get started. As I mentioned, OCI reclaims preemptible instances when capacity is needed. And I want to give you a little bit of understanding about why we do this so you can understand the model and understand our motives. Basically, OCI maintains an excess capacity buffer to support organic growth of on-demand instances. Basically, this helps us make sure that you never have to ask the question, gosh, will I have enough capacity to expand in the future? So that's one of the values we bring to you as part of the cloud, is that we take care of all the capacity planning and you don't have to worry. In order to do so, we always need to have more instances on deck than are being used. And what we do with preemptibles is we offer preemptibles on that excess capacity. Now, definitionally, because that capacity buffer there is there in case it's needed. If it's needed, you need to take it back. And that is when you would get a reclamation event. So for example, let's say an internet provider went down and there was a region failover event, and there was a big burst in one region of on-demand instance creation for people doing disaster recovery. If we did not have enough capacity on hand to fulfill all the requests immediately, we might take some preemptible instances back to help fulfill the demand for on-demand instances. Now, as soon as failover drains, preemptible instances come back, they come right back online, and you can pick up where you left off. And it's important to understand that while that kind of thing is rare, to make sure that your workloads function well on preemptible instances, you have to make the assumption that reclamation can happen at any time. We specifically don't make any promises about how long a preemptible instance can run for that reason. That being said, I can say we've done quite a bit of work to make sure that anytime you create a preemptible, you will get a very good amount of time to do useful work before you really need to worry about a reclamation event. And now, if you want to be notified when an instance is going to be reclaimed, we publish a notification event. You can see the JSON for that on the right through the events service. We target a 30-second notice, advance notice period. So our goal is to make sure you have at least 30 seconds between when you receive that event and when OCI goes in and reclaims the instance. And the mechanism for reclamation is instance terminate. So what would happen is you get a notice, you do whatever work you need to do. If you need to, I've seen many workloads that don't care, they're fire and forget, so they don't even worry about this. And then the instance gets terminated by OCI. Now, 30 seconds is our target. Your mileage may vary. This is a best effort on our part. My observations to date is it's usually much longer than that. I've seen it get as high as 2 minutes and 30 seconds. That is something that we are hoping to bring a higher commitment to in the future, longer and longer runtime. Our goal is to get above 2 minutes. So depending on your needs, I'd really encourage you to play with this a little bit. I'll show you how to set up a simple reclamation handler, and you'll be able to explore this yourself. And one very key point, there is no way to stop reclamation by definition. Again, we're able to offer this discount because we're running on excess capacity. If that capacity is needed for on-demand instances, we have to take it back. So there's no way for you to say, hey, now's not a good time to reclaim my instance. When they're needed, they're needed. In the future, we may add some things like automatic upgrade to on-demand instances. As it is today, though, assume that if you get a reclamation notice, the instance is going to be terminated. Now, when you get one of these notices, you can do a variety of things. Just as an example, you could save your state to an attached data volume. And then once the instance is terminated, you could then later request another instance, reattach the data volume, and just continue processing. And this goes back again to thinking about what does it mean to run a workload in an ephemeral compute environment, and just persisting things to shared data volume is a good way to get started. So let's talk about billing. Preemptibles, I mentioned, are billed at 50% reduced cost. The mechanism for that is not actually a direct unit price reduction. The way we do this is we actually reduce the amount of usage we bill you for by 50%. And that makes it easy for this to be a stacking discount because all your existing discount structures apply to what you're charged. The reason you need to know this is if you look into the details, you may see that you're being charged the full unit price. For preemptibles, you just have to look at the billed usage versus actual usage. Billed usage will be half of your actual usage. And preemptible instances are billed on a different meter against the same SKU. It's very important for us to maintain a smaller list of SKUs, or as small as possible. We want to keep this simple, so we're not introducing any new SKUs with preemptible instances, but you can differentiate charges against a different meter if you want to. You can also aggregate those at the SKU level. We'll look at that in a second. If you're at all familiar with capacity reservations follows a similar model, except at an 85% of actual usage. So this is consistent, the models we're using here as we differentiate across different behaviors within SKUs is consistent. Now, if you want to get into exploring your costs, looking at preemptibles versus on-demand charges, you can use the cost analysis tool. You can go in and you can pivot by service, you can look at SKUs, and you can look at meters. You can differentiate and look at your charges per SKU side by side. So you can see your capacity reservation charges, your on-demand instance charges, and your preemptible charges side by side. And this helps you to understand at the SKU level where your costs are coming from. It's also a really helpful tool to try to optimize your costs. In many cases, if you look at your consumption at the SKU level, the more capacity that you can be consuming as preemptible instances, the more cost efficient you're going to be. So you can go into this tool. It'll give you a lot of different ways to pivot and aggregate. Recommend you take a look at it if you're using preemptible instances to keep track of your charges. And if you really want to get into the nitty-gritty details, you want to get down to looking at charges at the resource level, the usage and cost reports will give you the level of information you need. You can look at the usage report, you'll see your full amount of usage. You can look at the cost report, you'll see the usage and the billing for that usage. You'll see that the unit price is the same as on demand, but you'll see that the billed quantity is half of the actual usage quantity. I will warn you that those two reports are actually in different units, so make sure you convert them if you're comparing them directly. As you can see here, I'm looking at the line item billing for individual resources. I can see what I billed, what the billed volume was. I can see the description of what the resource is, what the unit price was, and what my total charge was. So we have all the capabilities you need to go in and reconcile this at a very fine degree of detail. So that's a little bit deeper look at the experience end to end. Do a quick time check. Let's take a look at another poll. Now that you have a little bit more understanding of what the experience is, a little more understanding of what it means to think about running workloads in a running interruptible workloads on preemptible instances. Think again about all of the different instances you run in your on-premises environments, in your cloud environments, regardless of provider. Please answer this question as to what percentage you would consider running as preemptible instances. Awesome. Seeing a good distribution between 1 and 20% actually, so that's great. All right, if you have not answered the poll, please do so. We'll go ahead and move on. Appreciate your feedback. All right, now let's move into some demos. I'm just going to show you two things. First is how simple the instance creation experience is. We'll just walk through that. It's going to be fairly simple. And then I'm going to show you how to set up a exploratory experience for just being able to consume instance reclamation events. And what this is we're going to set up something just clicking through the console that will send you an email anytime there's an instance reclaimed anywhere in your tenancy. This is a really good way to get started because you can use the same setup and just plug it into a function, for example, to actually get started with an orchestrated workload. So this is an area where I find people get hung up a lot. They're kind of like, how do I connect this to that? How do I get these events? So I'm going to show you, you can literally do it in the console in 5 minutes. We'll do it together. So let's start off with instance creation. All right, now what we're going to do is we're going to just create an instance. I showed you a couple of screenshots, so this will look familiar. I click create instances or create instance in the compute section. And this is the instance creation form for folks who are familiar with it. I'm going to name my instance something, my preemptible test maybe. I'll select the AD I want to create the instance in. Then I click show advanced options. And this is the major point. I need to select what type of capacity I want to use. It's on demand by default. I'm going to click preemptible capacity. Now, this is important. By default, we delete boot volumes for you. And this is very important to consider when you're creating preemptible instances. When you are dealing with on-demand instances with a fixed fleet size, typically you don't think about your boot volumes that much. Very important. As you cycle through preemptible instances, if you don't have your boot volumes cleaned up, they will pile up. You don't want that. So if you are not explicitly maintaining boot volumes and passing them around between instances, make sure you leave this checked so that the boot volumes will be deleted automatically. Also understand that is the default behavior. So if you are using preemptibles and storing things in the boot volume and you want to control that process, make sure you make the appropriate selection here. Other than that, everything's pretty much the same. Select your image. I'll go into change shape here. I'm going to choose an E3 in this case. Let's go with the default size. You can configure networking if I want to. The keys, I'm not going to do that right now. And click create, and that's pretty much it. There's really no other differences. So as far as just getting up and running, it's very easy, and you can see it right away on the instance detail page, whether or not it's a preemptible instance. All right, now a larger task awaits us in understanding how to set up consumption of reclamation notices. So in order to do this, what I'm going to do is I'm going to do three things. I'm going to create a topic, I'm going to create a subscription to the topic, and I'm going to create an event rule which will route preemptible reclamation events to my topic. So I will start off by creating, okay, so I'm going to go to developer services. Then under application integration, I'm going to go to notifications. This is where I'm going to set up my topics and my topic and my subscription. So I'm going to create a topic. A topic is essentially a named endpoint where messages can be delivered. The event service is going to use this. It's very simple. Just remember, there's 3 steps: create topic, create subscription, create event rule. So for my topic, I'll create something like preemptible topic. All I really need is just a name. There's some other options here. I don't really need anything in this area. So I'm going to create this topic. Now I have a named place to send preemption notices. I'm going to create a subscription, which basically is instructions to OCI to what to do with messages that are sent to my topic. So I'm going to select the topic here. You'll notice there's a lot of things you can do here. I encourage you to explore. We're going to just use email for simplicity, but you can use this mechanism to execute a wide variety of activities. So do explore that. For right now, I'm just going to enter my email address. And again, there's more options. Don't need to do anything else. Now, what this is saying is when a message gets sent to this topic, send an email to this address. I'll go ahead and create it. And I'm done there. Okay, so now I've got my topic. See, that was very simple. I've got my subscription to my topic, which is my email. And now I'm going to go create the rule itself. So I go into observability and management under the event service. I click rules. Now I'm going to go create a rule. I'll just name it something like my test rule 1. Now these are the options you need to pay careful attention to. First, I'm going to create, the condition is going to be event type. Very simple here, just things you need to remember. Under the service name compute, this is it's coming from the compute service, obviously it's compute instance. The event type is instance preemption action, and this is just something you need to write down. This is the type of event that's coming from the compute service that you want to handle. So this is telling the event service, look from the compute service for instance preemption actions. And that's it for setting up the rule. Now you're going to tell the event service what to do. This again is an opportunity to do a lot of really cool stuff. Like if you want to do orchestration, you can just select function here, write a function to do whatever you want, whether that's balancing workloads across instances, creating new instances. We're just going to use a notification just for simplicity. We'll try to do this. And here's the topic I just created. And that's pretty much it. So if you think about what's happened here, I've told the event service, hey, look at the compute service, look for preemption actions, and if you find any, send a message to this topic. We created the topic. Previously, we attached a subscription to it. The subscription just sends an email. So when I go ahead and I create this, that's pretty much it. I wanted to show you there is another step that'll come up. You'll get an email when you create the subscription saying, do you want to, I'll show you what that looks like. You'll get an email like this. It says, hey, you just created a subscription with this email. Do you really want to do that? You need to confirm the subscription. Subscription confirmed, and that's it. So if you do exactly what I just did, you will now get an email anytime any preemptible in your preemptible instance anywhere in your tenancy is reclaimed by OCI. This is a great way to start exploring it and seeing what you can do. The other benefit here is, as you saw in the rule definition, if you want to start doing real work, you want to create a function to handle these notifications, to do something with them, you use the exact same steps I showed you to create all the connections between the compute service and your logic, which actually gets executed. Instead of selecting a notification, you would select a function. There's a number of other ways to do this. And the message payload has information about the instances have been reclaimed. You can use that to do activities of your choice. All right, so that's it for demos. I have heard kind of a recurring pattern of questions So I put together a little fact here. You can snapshot that. You can say that, do whatever you want. These are the most common things we hear. I won't go through this. These are just a quick answer card for the most commonly asked questions. So feel free to reference that if you'd like. The deck will also be available after the presentation. And we addressed all of these points in our discussion today. All right, so before we go to Q&A, I want to tell you where to find some additional resources. Product documentation on preemptible instances has pretty much everything you need to know, covers almost everything I discussed today. We also have a blog we've released that discusses preemptibles at a much higher level. So if you need kind of a pitch angle to this, or you just want to reference kind of the overall strategy, and we talk a little bit more about cost comparison with other providers, that's a good place to go. Now, I know links are not the best thing to do, or not the easiest thing to remember. So if you ever just say, hey, I need to find out about OCI preemptibles, just do a search on Google or the provider of your choice and say OCI preemptibles. You'll see the product docs come up quite prominently. So that's an easy way to get to it. Also, feel free to reach out to me. I'm always excited to jump in with folks who have use cases where they want to apply preemptibles. Feel free to contact me if you'd like more information. Especially if you'd like to share what you're doing with preemptibles. We're constantly collecting information on that. So let's switch over to Q&A now. We'll take a look at some of the questions that have been asked during the session. Feel free, if you have questions now, to put them in chat. I'll read through some things and answer questions as they come up. Okay, first question. My esteemed coworker Art has been answering questions. So the question here is, what if all of my web servers get interrupted? That's a great question. You need to assume that that can happen. So if you have a situation where you need a minimum guaranteed capacity, we have something in our product planning that we'll be offering in the future, which is will give you the ability to say, I want to have for example, let's say an instance pool, and I want a certain percentage of it to be on-demand instances, and I want a certain percentage to be preemptible instances. That's something we're considering support for in the future, which would answer that use case exactly. But you need to, with what is available today, you do need to handle the case where potentially you lose all your preemptibles at once. We will address that in the future, though. And another question, is there a way to stop preemption? As I mentioned, this is something we hear a lot. The way that we will address this in the future is giving you the opportunity to upgrade to on-demand. Right now, the answer is no. And to tell you why, again, we run on excess buffer capacity, which means we may need that excess buffer capacity. If we are in a situation like, for example, a cross-region failover due to another company's, like, for example, an internet provider's outage, and we need that capacity to handle disaster recovery, we have to take it back. We can't allow the preemptions to be canceled. So as of today, no, there is no way to interrupt a reclamation action. To another question, after a reclamation event, does it come back? That is not something we support today, but it is something we're planning to in the future. We call that a persistent preemptible. What would happen in that case is, if you're preempted, we'd save your state. When a new preemptible is available, we would reload it for you. We have not implemented that yet. So today, if a preemption event happens, you would have to request another preemptible instance and restart processing. But we do intend to address that in the future. Okay, how do you distinguish regular versus preemptive instances? In your bill, you will see a bill against the same SKU, but you will see a different meter. So you can just look for the different meter. Okay. Is there a resource? Is there an interface that lists preemptible resources available for region? You can look at the list instance API if you're looking for just a resource or some kind of capability that will tell you what shapes are available. I would recommend you look at the product documentation for that. Something we are considering is both a console-based and API experience that will allow you to look and see which regions or ADs have the highest availability of preemptible instances so that you can select those to have the least likelihood of being interrupted. We don't have that available today, but that is something we're considering doing in the future. Okay, any other questions, please feel free to reach out offline. Again, we'll publish this, this discussion for your reference. Please reach out to us. You can also talk to your customer support agent, reach out to me directly, happy to answer your questions. With that, I'd like to thank you for attending today. It was a pleasure speaking with you. Always a wonderful opportunity to share some of the great work that the team has been doing. Strongly encourage you to check out preemptible instances, play with them a bit. I gave you a couple of demos that should help you get started very easily. With that, thank you for attending. Hope you enjoyed it. There's a couple of questions that'll be coming right afterwards. Poll questions, please answer those if you have a few minutes. But thank you again for the opportunity to chat, and have a great day.
Thank you so much, Sam, and thank you, Art, for being in the Q&A as well. As Sam mentioned, there's a poll up there if you want to drop some answers in there. And if you want to join us on the Cloud Customer Connect forums for any future questions, we'd love to see you there as well, and future events on Thursdays and Tuesdays. Thank you so much, and have a great day, everybody.